Good morning. All right, so we are ready to begin chapter 4, if I can find my spot. There we go, chapter 4. All right, so today we're going to be, this is day 11. I don't know if you're looking at your daily schedule, but this is day 11. We're going to have 2 worksheets and 2 sections today. So we're going to look at page, I think it's 80, it's page 85. It's where it says chapter 4 begins. We're going to look at multi-digit multiplication and division. You're like, I got that. I know how to do that. Yes, you do. I know you do. But we're going to look at it a little bit differently. We're going to take a look at the algorithms. See that word right there at the in the middle of the page? We're going to take a look at the algorithms, or the step-by-step methods that we use to multiply and divide. We're going to kind of look at the why behind all of it. Okay, so you're already familiar with these methods. We're just going to take a closer look at them and seek to understand the mechanics behind them. I don't like to make a really long video because I know that you can read and you can do things on your own, but this one was a little bit tricky, so I kind of wanted to walk you through it a little bit. All right, so here's the concept behind the methods. All right, so I'm down kind of towards the bottom. Rather than jumping to the method we typically use to multiply, we're going to first explore the concept of what we're doing. Suppose we needed to multiply 9 times 12, which is another way of saying 12 9 times, but we had only memorized our multiplication facts through 10. This is just for pretend. All right, so there's you some pictures of 9 groups of 12, which pictures 9 times 12. All right, flip the page over. And it's going to kind of walk us through it. Since 12 equals 10 plus 2, when you break that out, we could think of each group of 12 as a group of 10 and a group of 2. So there's your picture. Okay, so that's the box of 12. Well, they've broken 12 up into a group of 10 and a group of 2. So we could find the product of 9 times 12 by multiplying 9 times 10 and 9 times 2, and then adding those products together. So there they have it written out. They have those 9 boxes of 12 where they broke it into 10 and 2. All right, so they have 9 times 12, which is 9 groups of 12. I'm right below those pictures on page 86. So 9 times 10, 9 groups of 10, plus 9 times 2, 9 groups of 2. So 9 groups of 10 gives you 90. Plus 9 groups of 2 gives you 18. So you would add 90 and 18 and get 108. Notice how we just solved that multi-digit problem by treating each digit as a separate problem. This, in essence, is all multiplication, what all multiplication methods do, except they use place value to automate the process more for us. In other words, what we do, just our normal little when we write it down and we carry and count on our fingers and all that kind of stuff, that's our normal method, but this is showing what we're doing. Keep this in mind. Let's take a look now at 2 different multiplication methods and see their different approaches. Now, this one's the one that was brand new to me. I had to really study this for a while. In fact, I've been studying it for about 30 or 40 minutes. I've never heard of it. Nothing that you'll ever use, but this is something that is going to just kind of broaden your idea of multiplication. All right, this is called, I'm guessing at this, the Gelosia method. These are some basic instructions to find out 9 times 12 using the Gelosia method. Now remember, because we serve a gracious, mighty, and perfect God, 9 times 12 is always 108. That's just part of the consistency of who God is and what He's done in math, or with math, for us. But we're just looking at why is 9 times 12 8. And this is just another method. I think if I am correct, I think this might have come from Asia many years ago, maybe something that they did way back in the ancient times. So here's the steps. So you're going to draw 2 squares, because remember we're just doing 9 times 12, and you're going to divide those squares into triangles. So there you go. The step number 2, write the 2 numbers being multiplied above and to the right of the square. So there's your 12 and there's your 9. Now, up on top of page 87, number 3, write the answer to 9 times 2 in the first square. See how they put 18, 18. They have the 1 and the 8. Okay, write the answer to 9 times 1 in the second square. Okay, all right. Add the numbers in the little triangles diagonally from right to left. In the first diagonal, we have 8. So we write 8 beneath the triangle. This is in the 5th step. Okay, and then you're going to go this way. You're going to go to the left, and they shaded those to show where we started and what we were adding together. The triangles with the 1 and the 9 are both within the same diagonal, so we add those together and get 10. We record the 10 as shown below. So I'm kind of at the bottom here of page 87. See where there's arrows pointing to where they put the 1 and the 0. Now basically what they did with that 1 from the 10 is it was actually carried over. Okay, step number 6. Reading the number from left to right, we get our answer of 108, 108. So 12 times 9 is 108. Easy peasy. Now, we're going to take a closer look at what happened here. In the Gelosia method, the squares and triangles separated our ones, tens, and hundreds. When we multiplied 9 times 2, we wrote the 1 part of 18 in the upper triangle because that 1 really represented one group of 10. Likewise, when we multiplied 9 times 1, we wrote the 9 in the 10 section of the second square because the 9 really represented 9 tens. The 1 in 12 stands for 110. So when we multiplied 9 times 1, we were really multiplying 9 times 110. When we added up the triangles diagonally, we were really adding up our 1s and our 10s to find our total answer. Truth be known, it's the same thing that we do when we sit down and just write 12 times 9, underline, same thing. It's just we're doing it without the triangles and the squares. All right, turn to page 88. Now this at the top of page 88, it shows you little squares, and it kind of shows you where your place values are here. Notice how the Gelosia method is a simple way to keep track of place value while we multiply. Rather than thinking 9 times 2 and 9 times 10, we thought of 9 times 2 and 9 times 1. This method made sure we wrote the answer to 9 times 1 in the tens place, since that 1 really stood for 110. See, it just kind of goes by place value. To solve problems involving more digits in the Gelosia method, we would just draw more squares. In the figure below, since we have a 3-digit number, we draw an extra row of squares. Notice that whenever we got an answer of 10 or greater, when adding the diagonals, we mentally added the tens digit to the next diagonal, thus letting our diagonals keep track of place value for us. Now, I'm fixing to put this on the screen, and it's going to be empty except for the 78 times, because our problem is 78 times 455, which gives us our answer 35,490. You see all those digits. I studied that triangle, that thing forever, and I finally got it figured out. I kind of had to look it up and get some help, but we got it. So I'm going to put it on the screen, and I'm going to walk through those steps with you so that you'll see how they came up with that answer. Okay, here is our square. This is the same thing that's on page 88 in your book. And here's the problem that we're doing, 78 times 455. So you're going to, make this little square doohickey thing, do all your diagonals, 78 times 455. And however many digits you have is like if this was 3 digits, you would have had another, square area over here. But we're just going to do this one. All right, now here's how they did it. They take 7 times 4 and they put the answer 28. Then they took 8 times 4, which is 32. Okay, and then down here they took 7 times 5. Put the answer to that. And then 8 times 5. Okay, 7 times 5 then is 35 again. Oh goodness, sorry about that. Let's erase that. 35. And then 8 times 5 again is 40. All right, so take a look. my numbers in here should be the same as what's in your book on page 88. All right, now this is the part that really confused me. I understood this part, but this is what I couldn't understand. All right, so I don't have very much room down here, so that you may not be able to see my numbers when I write down here. Basically what they do now I'm going to change colors here so it'll be easier to see. Okay, right here what they did was they start right here in the far right hand corner. And what they do is they start adding up. All right, so this is 0, so we're going to put 0. Woo. Yeah, see, I don't, no, that's 0. Let's erase that. One more time. Okay, so this is 0, so we're just going to put a 0. I don't have a lot of room. Ooh, it's going to be a little 0. All right, then what they do is they move on to the next diagonal set. 5 plus 4 plus 0 then is 9. Then they're going to move to the next set of diagonals, which is here. Because remember, it moves from right to left. So here, here, now here. All right, 3 plus 5 is 8. Plus 4 is 12. Plus 2 is 14. Okay, but what about the 1? Well, we're mentally going to carry it right here. Because now this is our next diagonal. And we're mentally carrying this. All right, 3 plus 8 is 11. Plus 1 is 12. 13, 14, 15. Mentally carry this. And this is the last one left. And it's this. So we read our answer this way. 35,490. And there you are. That's how they did it. They just go here, dun, 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 dun. And if they have to carry, they carry just over in the next one. That's how they came up with that answer. All right. All right, I hope that Jalosia method made sense to you. All right, we're going to move on to the next section. It's called the traditional method, which I'm sure you're pretty aware of that. So let's look at the bottom part of page 88. We're going to kind of walk you through this a little bit. I'm also going to kind of walk you through the worksheets a little bit today as well. A very similar thing happens in the traditional method with which most of us are familiar. Rather than jumping right to the final way that we multiply, let us develop the method step by step by breaking apart 9 times 12 into smaller problems, 9 times 2 and 9 times 10, and then solving it. So here they write 12 times 9 like we traditionally would write. Now they're going to say in their minds, they're doing 9 times 2, adding the ones, multiplying the ones column. 9 times 2 is 18, so they put 18. Okay. Then they're thinking 9 times 10, multiplying by the tens. And that's 90, so they're going to write that down. And they're going to add it up. We get 108. It's kind of what we did at the beginning. All right. Now, when we have a task to do over and over again, it's always good to find ways to save steps. And here's what they do. This is our method. This is what we do. Okay, so we think 9 times 2 is 18. So put your 8, carry your 1. And then 9. Now I'm at the top of page 89 now. Now we work with the tens column. 9 times 1 is 9 plus 1 is 10. So we put our 10. Now notice under that 8, there's a 0. Remember we always put a 0 there because we're showing that we're not in the ones place anymore. We're moving over. The place that you are not in, everything to the right of where you're working with down below, you got to put a 0 there. And then you add everything up, you get 108. Now there's still a way to save steps. Okay, so look now, they had 12 times 9 and they just put 108 because you just do some of it in your mind. You know that 9 times 2 is 18, put your 8, carry your 1. In your mind, you say 9 times 1 is 9 plus 1 is 10, so you just write that and you're saving a step. Easy peasy, thinking of it in your head. Now to multiply a 2-digit number by a 2-digit number, you'd follow a similar procedure, except you'd have to break it down a little further still. So let's say we want to multiply 29 times 12. We can think of this, 9 times 12 and 20 times 12. Remember the 2 in the 29 represents 2 sets of 10 or 20. Now we can break down both problems. We're going to do it just like we did before. So 12 times 9 first. Okay, so 9 times 2 is 18. Put your 8, carry your 1. 9 times 1 is 9 plus 1 is 10. So put your 108. There we go. Now multiply 20 by 12. Okay, because remember the 2 and the 29 is actually 20. All right, so you're going to come down below the 108 and you're going to put a 0 there, like I said, because that just says I'm done with the ones place. I'm moving now to the tens place. I'm going to multiply in the tens place. That's why we put that 0 there. It's kind of a placeholder reminder where we finished. Okay, now you start multiplying. You know that 2 times 2 is 4. Put your 4 and put it right in the right column. Then you say 2 times 1 is 2. Turn the page. Put your 2. And then you add up all your products. 108 and 240 would be 348. That's traditional, but it was just walking through the method so that you can understand why you do it that way, why we break it apart. Those are algorithms. You can use this algorithm or this method to multiply numbers regardless of the number of digits. All right, and then it kind of gives you the step-by-step place and how to do it. Now, look at the top of page 91. Now, I don't know about you, but I would have written it the other way around because it would have been easier for me to do. But they didn't. But they're just walking you through 123 times 2,561. This is traditional method. This is how you've been doing it. I would have a sneaking suspicion that you don't have any trouble getting this figured out. So I'm not even going to walk you through that because that's just regular traditional method. But notice at the end of that, right in the middle of page 91, notice all those zeros there. Notice in the ones place there's 3. Notice in the tens place there's 2. In the hundreds place there's 1. Because you're multiplying by a digit that's got 3, a number that has 3 digits. And so each time you scoot over a place and add a 0 to where you've finished and then go on and move. All right, then you add everything up and that gives you your answer. Okay, so that's traditional. That's just what we do. Just gives you an idea of why we do it that way. All right, now turn the page. We're on the second part. Now this is going to go over a property, the distributive property of multiplication, better known as just the distributive property. All right, now we're going to look at 2. If you'll look at the very top, 2 and then in parentheses 3 plus 4. That actually we would say 2 times 3 plus 4. Anytime you start adding a whole bunch of numbers in there, thinking of order of operations, anytime you have a number right beside a parentheses, that always means to multiply. Any 2 numbers beside each other with just a, we're not doing the X anymore for multiplication because we're getting into harder things where we're using letters for different things. So don't ever use the X anymore for multiplication unless you're doing just a traditional method that we just did. But when we have an equation like this, we put them side by side. All right, so here it says the distributive property of multiplication. Up until now, you've solved problems such as 2 times 3 plus 4 by adding the number in the parentheses, because remember, we've always been told, do parentheses first. All right, and then multiplying. If we do this, we get 2 times 7, which equals 14. And there's you a picture. It's 2 sets of 3 plus 4. Add it all up, you get 14. Notice we get the same answer, though, if we do it another way. If you distribute the 2 to the add-ins in the parentheses, and this is what I mean. Let's look over at page 93. No, bottom of page 92. All right. Look at, you see where they have the 2 sets of 3 and the 2 sets of 4. We're looking at this differently. Now, this is 2 times 3 plus 4 in parentheses. But what if we take the 2, rather than do 3 plus 4 first, take the 2 and multiply it by each of those add-ins and then add what we get. For example, 2 times that first add-in is 3. 2 times 3, we get 6. And then 2 times the second add-in, which would be 2 times 8, which would be 16. 2 times 4, which would be 8. So then you're going to add 6 plus 8, you get 14. Ta-da! You get the same thing. All right, so go ahead and look at the top of page 93. It turns out that no matter what the specific problem, multiplication can be broken out between add-ins this way without affecting the result. We call multiplication's ability to be distributed between addiends that make up a sum the distributive property of multiplication, or just the distributive property. That's a mouthful. It's essentially a way of naming an aspect of how God holds something together. Calling this property the distributive property makes sense since the word distribute means to parcel out. When we distribute, we're parceling out the multiplication over several addiends. So that gray box in the middle of page 93 with a big gray arrow pointing to it means remember this, remember this. You might want to write it down maybe on a little note card or something, just to remember what the distributive property of multiplication means. Okay, now that comes to the end of that. Now we're going to go ahead and work on our work text pages. Now you're going to be doing 4.1 and 4.2. Now on worksheet 4.1, on number 1, you've got 3 problems where it wants you to draw out that Gelosia method. Now, I'm not going to grade 4.1. I don't think I'm going to grade 4.2 either. Yes, I am going to grade 4.1. I want to grade 4.1, but I'm not going to grade the Gelosia. I'll use the Gelosia method for bonus. How about that? So, because it's not anything you just have to know, it's just something for you to show that you understand. Okay, so you're going to do 4.1. I think you can do that. Now, on number 2, on the traditional method, just on A, B, C, and D, just write it out, write the whole problem out, and get your answer. Just normal, like we always do. Just normal method. And then on the back of the page, there's some problem solving. Right above number 4, while you can do all but the solving step mentally on these problems, be sure to still think through what you're doing and check to make sure your answers make sense. Okay, look at number 4. It says salary. At $875 a month, what will a man's yearly salary amount to? How are you going to figure that? It should be $875 if he gets paid once a month times 12. So you'll have to figure that out. All right, and there's another one on 5, 6, 7, and 8 are some questions. On number 7 on the skill sharpening, I believe these are place value. Not place value. Not place value. What am I thinking of? Order of operations. So you can do on 7A and 7B, do it whichever way is best for you. Okay, look at worksheet 4.2. Now, on number 1 at the top, it says distributive property and actions. Show that you solved using the requested method. Notice that you get the same answer each way. So you have A, B, C, and D. So on A and B, it's the same equation. It wants you, on the first one, it wants you to just solve it using order of operations, which would be 2 plus 6 is 8. So you're going to end up with 3 and then 8 in parentheses, which equals 24. That's using order of operations where you do parentheses first. Now, on B, it says solve using the distributive property. So you're going to show 3 times 2 equals 6, and 3 times 6 equals 18. Then under that, you're going to show 6 plus 18 equals in your answer. Okay, so it's kind of a step by step. I want you to show me your algorithms. Show me your method in getting it. I know sometimes it's easier just do it in your head and get it over with, but I want to see it. And you do the same thing on C and on D. But notice on D, they put the 5 at the end. It doesn't matter. It does not matter. With multiplication and addition, the distributive part, it does not matter where those are. You're still going to have 5 times 17 plus 5 times 15, or 5 times 3. Okay, so that should be pretty easy. Number 2, you're going to have to go back and look in the last chapter. Chapter 3 went over those different properties. So if you don't know what property that is, go back and look at those properties. And then on number 3, breaking up large numbers, it gives you an example to follow. Super easy, just follow exactly how they showed you. It's very, very easy to follow. Number 4 on the back of the page, you'll have to break them up mentally. Try to do it mentally. And then you have a problem-solving practice. Okay, so let me make a note to myself that I'm going to grade, and I'm sorry this lesson was so long, and I hope I didn't bore you half to death. So 4.1, I'm going to grade 2 through 8, and number 1 for bonus. I'll count how much it's worth and I'll put that on Google Classroom. And then 4.2, I like to give a grade because I know you work hard for these. I think I'll grade 4.2 completely. Yeah, so I'll just grade it and I'll tell you how many points it's worth on Google Classroom so you'll know. If you have any trouble, if you don't understand something, please let me know because I don't want to go further until you completely understand. Okay? Well, that's all for today.